Here we go. Good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off or use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to finish up chapter 8. We're going to look at section 8.9. Tonight's homework will be section 8.9 as well as the chapter review. Tomorrow we will review, and then on Thursday we'll have the chapter 8 test. So let's go ahead and get started on the last section of this chapter, which is, again, section 8.9, which is called variation. All right, there are three types of variation that we're going to look at today. Each one has its own formula. We'll look at the formulas and then examples of each. The first example is called direct variation. A general form of the formula is y equals kx. K is called the variation constant, or the constant of variation. I think it's even called the constant of proportionality. I like to stick with variation constant because that's the shortest description, or the shortest definition. Anyway, so what will happen, K will be present in all of the formulas that we look at, though often it's not even mentioned, but we'll be given information and we'll use it to find K, and then we'll be given some further information to solve the problem. So let's go ahead and take a look at a first example, and this is what it says. It says free fall. An object in free fall travels a distance s that is directly proportional to the square of the time t. All right, and that word proportional, they throw that in there, variation, proportionality. Let's put it this way. An object in free fall travels a distance s that varies directly to the square of the time t. So s is the distance that an object falls, and t is time in seconds. Okay. Now, it says an object in free fall travels a distance s that varies directly to the square of the time t. So our formula, instead of y equals kx, we're going to be using s and t. So s equals kt squared. Again, let me read it. An object in free fall travels a distance s, okay, that varies directly to the square of the time t. So that's where we come up with this form. Any questions on that particular situation? All right, now it says if an object falls 1,024 feet, so that would be s, in 8 seconds, how far will it fall in 10 seconds? Well, now that we're given a value of s and a value of t, we can determine what k is for this particular example. So we've got 1,024 equals k times 64, or 64k, okay? Now, if we divide both sides by 64, let's see here what that is. So we have 1,024 divided by 64, and we get 16. So the variation constant for this problem is 16. Now we take that and we put it back into that formula, which gives us this. S equals 16 t squared. Okay, so we start with a formula. We're given some information allowing us to solve for k. We put that value in for k. Now we have the follow-up question. How far will it fall? So that would be the distance in 10 seconds. So t is 10. Now, a common mistake that students make is when they start plugging in variables or numbers for variables like they did here, they forget the squared. So be careful with that. All right, so what do we have? We have 16 times 10 squared, which is 100, or 1600, and that would be feet. So how far will it fall in 10 seconds? 1600 feet. Any questions about that situation, that example? All right, so that's direct variation. In direct variation, as one of the variables increases, the other increases. As one of the variables decreases, the other decreases. So they go up and down directly. Okay, now, second variation formula is called inverse variation. And a general form of this problem looks like this. Y equals k divided by x. So we have this reciprocal or multiplicative inverse situation. K is still present on top, but x is in the denominator rather than the numerator. In this situation, the way things happen, as x increases, y decreases. As x decreases, y increases. So there's an inverse variation. One goes up, the other goes down, one goes down, the other goes up. Okay. Now, let's see here. It says pipe organs. The frequency of vibration of air in an organ pipe varies inversely to the length of the pipe. If a pipe 2 feet long vibrates 256 times per second, how many times per second will a 6-foot pipe vibrate? Okay, the frequency of vibration of air in an organ pipe varies inversely. So we've got F is going to be frequency of vibration, okay? Varies inversely to the length of the pipe. So L is going to be length of the organ pipe, okay? So F is going to stand for frequency of vibration. L is going to stand for the length of the pipe. Here we go again. The frequency of vibration of air in an organ pipe, so that's F, varies inversely to the length of the pipe. Now, again, notice K isn't mentioned, but K is always there. K is always on top in all three of the formulas we're going to look at. K was up in the numerator here, and K is still in the numerator there. All right, now, if a pipe 2 feet long vibrates 256 times per second, how many times per second will a 6-foot pipe vibrate? So we have a length and a frequency of vibration. This allows us to solve for K. Multiplying both sides by 2, we get K equals what? 512, okay? So now we're going to take that and plug it in there. So our general formula now becomes specifically that. All right. Now we have a follow-up question. How many times per second will a 6-foot pipe vibrate? So we get 512 divided by 6. Now, here's where you need to be careful. Unless it tells you to, you never want to round off. Certainly not in the middle of a problem. 512 divided by 6. And what I'm getting is 85.3 repeating. That's 85 and 1/3. Okay, 0.3 repeating is 1/3, a fact you should know. So the frequency would be 85 and 1/3, what, times per second? times per second. Okay. Any questions on that example? So we've looked at direct variation, where as x goes up, y goes up, x goes down, y goes down, or whatever the variables are, they go up and down together. Inverse variation, when one increases, the other decreases, one decreases, the other increases. Finally, the last type of variation, joint variation. Joint variation in general looks like this: y equals kx, and we'll use z because that's what the textbook uses. Have you ever had a joint bank account? That's where there's more than one person on the account, like you and your spouse or whatever. So joint variation, we have more than one variable on the right side of the formula, the right side of the equal sign, okay? So let's see here, an example of joint variation. It says oil storage. The number of gallons of oil that can be stored in a cylindrical tank varies jointly as the height of the tank and the square of the radius of its base. The variation constant is 23.5. Find the number of gallons that can be stored in a cylindrical tank shown. All right, so let me draw a picture of the cylindrical tank, my attempt here. And it tells us that, let's see, this distance, the height is 20 feet, and the diameter is 15 feet, okay? The number of gallons of oil that can be stored in the cylindrical tank. So let's see, we're going to say G is number of gallons. Very gently, height of the tank, we'll say H equals height of tank. Square the radius of its base. R is the radius of base. Oh, the constant of proportionality, or the variation constant, is 23.5. So in this particular problem, not only is the variation constant mentioned, but it's given. So that's good. All right, so let's establish our actual formula. The number of gallons of oil that can be stored in a cylindrical tank, G, varies jointly as the height of the tank. So we've got K and then H, and the square of the radius of its base. So G equals KH R squared. So again, using joint variation, the variables were given, we get that formula. Now, I already know that K is 23.5. So I've got that. It says, find the number of gallons that can be stored in the cylindrical tank shown. Well, looking at the picture that I've drawn, this would be the height, right? So the height is 20 feet. 15 feet is not the radius, it's what? It's the diameter, right? The radius is half the diameter. So the radius, let's see, D would be 2R. So the radius would be what? 15 halves feet, or how about 7.5 feet? So we're to find the number of gallons. That's 23.5 times the height, which is 20 feet, times the radius, which is 7.5, and we square that, okay? So putting that all into the calculator, we've got 23.5 times 20 times 7.5 squared, and I get 26437.5, and that would be here. Gallons. So 26,437.5 gallons. Let's see. Okay, so the again, we have direct, inverse, and joint variation. Y equals kx, y equals k over x, and y equals kxz. Direct variation, they go up and down together. The variables do. Inverse, one goes up, the other goes down, one goes down, the other goes up. Joint variation, you have more than, it's a sort of an extension of direct variation. You have more than one variable on the right side of the equal sign. Okay, now I want to look at some translation from a written sentence into a formula, and then from a formula into a written sentence. So this says, express each verbal model in symbols. All right, it says A varies directly as S. So A equals KS. Don't forget about the proportion or the variation constant, excuse me. All right. How about this one? Z varies inversely as the cube of T. So Z equals K over T cubed. Okay, let's see here. D varies jointly as R and T. So D equals KRT. How about this one? It says P varies directly as the square of A and inversely as the cube of J. So here we have more than one type of variation in the same formula. P equals KA over J cubed. P varies directly as the square of A, the square of A, and inversely as the cube of J. Okay, so again, K is always there and always on top. Now let's go the other way. Let's look at some formulas and write them out in words. R equals KT. R varies directly as T. Let's see. A equals KR cubed. A varies directly as, as the cube of R. Let's see here. How about this one? U equals K R S squared T. U varies jointly as R, the square of S, and T. One more here. How about, let's see, that's U. R equals KL over D squared. R varies directly as L and inversely as the square of D. Okay. So you want to memorize those types of variation: direct, inverse, joint variation. That would be part of your assignment as you're going through and doing that. Get familiar with those. So that's all I've got for you today: direct variation, inverse variation, joint variation. Again, your assignment tonight is section 8.9, as well as the assignment on the chapter review for chapter 8. Tomorrow during class we'll review, and then on Thursday there'll be no Zoom meeting during class time. You'll just do your chapter 8 test. I will be back this afternoon at 1:15 with an office hour, should you have need of me then. Any questions before we go? All right, well then I will stop the recording.